Okay, so the first thing are the gray horns. They're actually brown on the model, and the only way we can tell the difference is which side they're on. Now, whenever you first look at one of these models, you want to look for two things, no matter which way it's presented to you. You want to look, one, to see which wings of the butterfly touch the edge. That's the dorsal side always. The other thing is, if you can't remember that, look for the onion. Let me hold it up so everyone can see. See the spring onion? That's also the dorsal side. So the side to which it connects is dorsal. Once you've oriented yourself, it's pretty easy. This is the anterior gray horn, lateral gray horn, and posterior gray horn, because this is on the posterior side and this is on the anterior side. And so that goes the same for the white column. So we have the anterior white column, the lateral white column, and the posterior white column. Central canal. They want you to know the gray and white commissures. Commissures mean that it's a connection. These are information that's traveling from one side of the spinal cord to the other. So you can see both an anterior and a posterior gray commissure, but we can only see one little bit of white commissure. It's only on the anterior side. They want you to be able to find the anterior medial fissure, which is definitely a strong fissure, and you can see that part of the meninges actually travels in there. And then the other thing is the dorsal medial sulcus. So study those two because they have different endings, and if you call it the dorsal medial fissure, that's not right. Meninges. So the three layers of the meninges are present here. 9, this outermost layer is the dura. So that this is the dura mater here. It's separated by a very thin space from the arachnoid layer. So this is the arachnoid. I think in the textbook it mentions the subdural space. Remember, that's a potential space. It should not be there. It has the potential to fill with fluid and blood in somebody who's having some sort of trauma, but it shouldn't normally be filled. Then we have the subarachnoid space in here. You can see it's very big to allow for all that cerebrospinal fluid. And then finally the white layer that's actually attached, that's the pia mater. So then we have our roots. You have a dorsal root and then the huge dorsal root ganglion. There, go ahead and take it out so that you can see it here, but I'm just as likely to pin it on the other side. So make sure you can take the information from over here and put it on this side of the model, which sometimes seems to cause problems. So the dorsal root ganglion, the dorsal root ganglion. All of this is the ventral root. So where the number is, but also over here is the ventral root. And then this is what it looks like, all covered up with the meningeal protection. Once they join together, it's a spinal nerve. So this area of joining is a spinal nerve. Now, that nerve is then going to branch, and one branch of it goes to the back of the body and the other branch of it goes to the front of the body. So those branches are called rami because that's what it means. Ramus is just a branch in Latin. So the dorsal ramus would be the one in the back going to the back portion of the body. The anterior ramus comes around and comes to the front, or the ventral ramus comes to the front. We have a special ramus called the gray ramus communicantes, and what that does for you is take information from the anterior root over to your sympathetic system, and from your sympathetic system back to your spinal cord, so that we can get rapid sympathetic responses, okay? And so these are the sympathetic tracts that are going to run all the way up and down that we'll need to, I think, see a little later. That's it.